Alright. So what I was saying about when I went over the homework is you may want to take with pencil and just plot the points of the parent function on your paper first. You can erase them later or you could leave them there. I really don't care. Let's go ahead and just plot the parent function, which would be 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0. Okay, so I just did those in like a light gray little pencil. Erase them later. Here, 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 here. You could do the other side too, but I usually can figure it out after I do a couple. But if you can't, do them all. Now, we need to do a couple things with these points. This negative is telling me that it's a reflection across the x-axis, which means those points are going to like fold down. Okay. This 2 tells me that this is an amplitude change of 2. And that will affect your max and min points only. Okay, the middle level points, the ones that are not peaks or pits, so these ones right here, are not going to get affected. But the max, the starting point, your y-intercept is a max. So that's going to get affected by the 2. And then that's it. We don't have any plus or minus. It doesn't matter which order you do these in. If you want to do the amplitude change first and then reflect it, if you want to reflect it and change the amplitude, it does not matter. I usually go in order. So I would take this point, I would reflect it down to negative 1, then change the amplitude to be a 2, which does not mean move it 2 spaces, just change it to a negative 2. So this would be where my new point goes, 0, negative 2. Again, if you prefer, you could have taken your starting point, changed the amplitude to 2 first, and then reflect it. Some students like that better. All right, now this is a mid-level point. The mid-level point does not get affected by either of those points. So this is going to stay right where it was. This next point, my parent function started here. Let's reflect it up to 1. Change the amplitude to be 2. If you prefer, again, you could change the amplitude to 2 and then reflect it. You'll get the same value. This is a mid-level point. It stays where it's at. And then at 2 pi, we had a starting point at 1. Reflect it down to negative 1 and change the amplitude to be 2, which makes it a negative 2. And then that gets me my curve. Okay, on the other side, it's just going to go in reverse. It's going to go up, up, down, down. And if you want to check it on your graphing calculator, do it. Type it in. Y equals negative 2 cosine x. Zoom 7. And you can at least match up and make sure that it looks like it's the same curve. All right, the next one, who could describe this translation for me? What's the negative 3 and the minus 3 telling me to do with it? Is that changing my amplitude? Is it shifting it left, right, up, or down by 3 units? Good, this is shifting it down. So you're literally just taking that whole curve and sliding it down on the axis. So the parent function, if you want, you don't have to do this. Whoops, that's my sine parent function. Cosine starts at 1, goes down to 0, negative 1, 0, positive 1. Take each of those points now and shift them down 3 units. So take this one, shift it down 1, 2, 3. Take this one, shift it down 1, 2, 3. That's it. Again, some of you that catch on like a little bit more quickly, some of you will just be able to move the starting point down and then you know the pattern. So you just like continue the pattern. But if you're not sure, always do the parent function first and then you can kind of just model from there. All right, example D. What kind of transformations and translations do I see here? Devin?
Reflection.
And? Good. So again, I'm going to put my parent function on there. Start at 1, 0, -1, 0, +1. Now this one, it kind of does matter which order you do it in, you will get different points. So it's easiest if you just read it from left to right. So you want to reflect it first. So it would reflect down to -1, and then shift it up 1 unit. This point, the reflection doesn't do anything because it's on the x-axis, but it does shift up 1 still. Think of the x-axis as being like folded whenever you reflect it. This one, reflect it up, shift up 1 after that. So it goes to 2. 3 pi over 2, reflection doesn't affect it, but it does shift up 1. And our last one started at 1, reflect it down to -1, shift it up 1 unit to get it back to 0. And then on the other side, you just kind of mimic that. So that they're always 1 space apart. So the closure says, what are some similarities and differences between the sine and cosine function? And this is actually going back to last week. Yes. The similarities would be their domain and range. Some of you also say they're shaped because they're both curved. The original functions too, they also have the same amplitude, right? They also have the same period, very good. Which the period, if you recall, is how long it takes for the cycle to repeat itself and start looking the same. And I have the same shape, I wrote that down too, in case you want it. It's not very mathematical, but it works. And then I heard you say the differences are the y-intercepts. And actually also the x-intercepts. We haven't talked about that before. We kind of did because we listed them. But where it crosses the x-axis is going to be different because the curve is kind of shifted. All right. The rest of the class period you can use, or I know some of you are leaving shortly because of early release. You're just finishing last night's homework. So whichever questions we didn't do on the 6-6 day 2, we'll finish this.